to the final days of Mathober. Mathober. I'm going to just keep calling it the wrong name forever. The next theme that I need to do a thing for is removable. And I know there's probably a lot of different things I could do for this, but this reminded me of a particular mathematical thing, which I'm going to attempt to approximate here. So this is the idea that if you're hanging a picture on a wall, people may have heard this before, but imagine this is like a picture I'm hanging on the wall, and I've got two nails to hang in the wall. There are ways that I could take a piece of string attached here at C. I could just put it over the top of the two things. I could do this kind of thing. I could make the string go over the top like that, and then it would be hung on the wall. But in that case, if I were to remove, no, I don't understand how polylines work. I'm deeply confused by polylines. Who knows? I'm just going to make a series of segments. That'll do. So if I were to hang it this way, if I were to remove either of those two pins, then the picture would still be hanging on the wall. And that's probably a good thing, depending on how you like your pictures hung. But it turns out you can do a thing with what are called commutators. So if I've got a thing, I'm going to count going round A clockwise as being the letter A, going round B clockwise as being the letter B, then the thing that I've just drawn there could be described as AB. But if I do AB, A inverse, B inverse, like that, then, where's it gone? It's down there. This is what's called the commutator of A and B. And if I were to draw this, good luck me. So I go, nope, not a line. That's going to make things a lot worse. Okay, so I go round A, I go round B, and then I need to go backwards around A, so I can do this. There's definitely a better way to do this in GeoGebra. And then I go backwards around B, if that makes sense. And if I was doing this with a real piece of string, you would probably be able to understand this. Then this gives you an arrangement, which if I were to remove either of the pegs A and B, then the picture would fall off the wall. And that's intriguing because you would think it's not possible to kind of hang it that way, but it turns out you can do this, and you can do this for any number of pins just by writing the commutator. And if we think about this group theoretically, removing the pin A, pulling that pin out, is equivalent to just deleting every instance of A or its inverse from this thing, because if I pull the pin out, anything that was wrapped around that in either direction is no longer wrapped around it, basically. So if I remove the two A's from this, the A and the A inverse, I would be left with B inverse, which is to say that the rope is going over B clockwise, and then it's going over it again anti-clockwise, and then it isn't attached to it, right? It's just these two cancel out in group theory. And similarly, if I were to remove B, I would just end up with A inverse, and that would cancel out as well. And you can do this with, you end up with like A, B, A inverse, B inverse, C, and then the inverse of that bit, and then a C inverse. Like you end up with something that's going to cancel out. But it's kind of a cool little thing, and if you've not heard of it, there it is.